Welcome. Today we'll be looking at the lesson entitled Rational Expressions Day 2. This is obviously the second part to the two-day lesson dealing with rational expressions. Day 1 dealt with simplifying and multiplying and dividing, and then today we'll be doing some addition, subtraction, and dealing with some more complex fractions. So what do you say we go ahead and dive right in? In fact, I look at example 1 here, and that seems to be a continuation of the end of the previous lesson. So example 1 just simply states, find the least common multiple. And as we all know, obviously, if we're going to add and subtract fractions, we need to come up with the least common denominator. And these are the steps we'll take in order to get them. So here's sort of what we did, if you remember correctly. We looked at the two values that are present. Usually they'll be in the denominators, but here they are just side by side. And what we're going to try to do is find out the least common multiple to those two polynomials. So in this particular case, if we've done it by factoring, if you remember correctly. So I look at this, though, and this x plus 2, and it's prime, of course. So oddly enough, I'm just going to go ahead and write it again just below here because that is the factored form. And then x minus 2, also prime, so there it is, no big deal. And if you remember, we have these two separate lists of factors, and what we want to do is take all of the values that are in both lists, but we don't want to include the redundancies, if you remember that, me using that phrase in the previous lesson. You'll see this in Part B, but not necessarily here in Part A. But with this being said, it looks like x plus 2. We take this one, so I'm going to go ahead and take that. Here it is. I'm going to go ahead and draw the arrow here. Not that we necessarily need it. So we've got it. That's great. And then x minus 2, we need that one from the other list. And as you can see, obviously, if we've got these two prime polynomials, the least common multiple would just be the product of them. So we took them both. Great. Let's move on to Part B then. So Part B gets a little more complex because we're going to actually have to factor these. And just to get this moving along, I'm going to go ahead and factor the left polynomial and then also factor the right polynomial and then ask you to see if you can come up with the least common multiple first before I do it. So anyway, looks like greatest common factor here. I'm going to pull out a 5 and an x, so 5 times x. And when I do that, it looks like I have a remaining factor, a binomial of x plus 3. So this polynomial in standard form can be written as a product of 3 factors, the 5, the x, and the x plus 3. Here we have a little quadratic trinomial, and so I'm going to go ahead and factor it into a product of its two binomials, and looks like it would just be x plus 3 times x plus 3. So here's what I'd ask you to do. Take a moment, pause the video, and see if you can use the factors in each list to come up with the least common multiple. All right, so let's see what you came up with. What I do first, and I believe I did this on the last lesson, is if I see some redundancies, I'm just going to kind of connect them. So this x plus 3 right here is the same as this x plus 3 right here. I don't need it twice because it is common to both lists. So I'm going to take the 5, just working left to right. I'm going to take the x, again working left to right. I'm going to take the x plus 3, and again, because I tied it to this one, I don't need this over here. I'm going to skip right by this because this is simply the redundancy of that. But if you do notice, there is that extra x plus 3, which is not tied to anything, and so as a result, I do need that right there. And long story short, everybody, that is what you should have come up with, and I'm hoping that you did. And if you didn't, that's okay. We're going to get some more practice on these as we do the addition and subtraction. All right, so I'm going to go on to my next page, and let's see what we have going on. So as always, I like to just give you a little reference to come back to. So you can always kind of look at the notes worksheet and see, oh, I'm not sure how to add and subtract. Oh, well, Mr. Meyer put some strategies there for me to take a look at. So I'll do a quick read through, and then we'll go through example 2. So strategy number 1, find the least common denominator. Absolutely, that's what we did in example 1, and we'll continue to do that. Number 2, rewrite each rational expression with your answer from step 1 as the denominator. Yeah, so we come up with our common denominator. Number 3, perform the operation or operations on the numerators. So we're going to simplify the numerators. So remember, multiply before doing any addition and subtraction. So just order of operations does matter. And when we do go ahead and add and subtract fractions, as we do know, we do keep the denominator. So the way I have example 2 kind of lined up, it's meant to have a concrete one, something you've seen many, many times before, and then using that process that we create with example 2a to go ahead and now look at it in more abstract terms. So a sort of a medium level problem, I suppose, for example 2b. And then C, which is not on my board right here right now, C is the harder one, and that's kind of the upper echelon of the level of what we're looking for. So here's how we're going to play it out. We're going to do part A together, and what I'm going to try to do is just keep consistent across the board here as we go through from easy to medium to hard. Now if you notice, I did, like on notes worksheet number 1, is deal with the restrictions on the domain. Obviously that's not relevant here for part A, but for part B and for part C we'll have to deal with that. Okay. Well, let's go ahead and try this out here. And really the first course of action is to go ahead and get the LCD. So I'm going to just do this off to the side. So LCD, and you don't have to if you don't want to. But in fact, I kind of look at 8 and 14. And if you can figure out what the least common multiple of 8 and 14 would be, then by all means, go for it and move on. That's great. But just for our purposes here, I'm going to go ahead and take each of these denominators, and I'm going to use the process that I did in example 1. So here's what I mean by that. If you notice, 8 can be written as a product of 3 prime factors, 2 times 2 times 2. 14, here it is right there, can be written as a product of 2 factors, 2 prime factors, 2 and 7. And so if I asked you to come up with the LCD based on this, I'm hoping this will be really nice just in case you're not getting it from the previous example. Well, I'm going to tie together anything that's common in both lists. So that 2 is the same as that 2. So I'm going to go ahead and take that. And then I'm just going to work left to right. And so here's the 2. Got it. Take that 2. Got it. Take this 2, which is common to that. I got it. And then it looks like the 7. So I hope that makes pretty good sense the way I laid this out, and it's consistent with what I've been doing all along. But now, when I go ahead and multiply all those together, 2 times 2 times 2 times 7, it looks like we are getting 56. And that, everybody, is our LCD. And that is the big first step, as you can see. Find that least common denominator. So now we know that we're going to try to write each of these fractions in terms of 56ths. So I was thinking about this, and I'm looking at my page as I'm working off of it. I'm going to rewrite this. If you don't feel the need to rewrite it at this stage, that's totally fine. If you can play along just up here, more power to you. But what I'm looking to do is take the 3/8 and the 1/14 now and write it in terms of 56ths. So here's what I mean by that. So one fraction, 56 is the denominator. Well, what does that mean for the 2 fractions that I originally worked with? Well, this left fraction and this right fraction I've got to deal with a little bit. So here's what I mean by that. If you look at the left denominator, obviously we talked about this. This is just 8 right here. I changed this 8 to a new denominator as 56. In fact, I multiplied this 8 by factors in order to get it up to 56. Well, the question is, what did I multiply the 8 by in order to get 56? Well, I multiplied by 7. 8 times 7 is 56. So what I really did down here is I multiplied it by 7. Now it's a fraction. And what we have to realize is we don't want to change the value of the fraction. We're not doing that. We're just changing the look of the fraction. Instead of in 8ths, it's in 56ths. So the way we deal with fractions is anything that you do to the denominator of a fraction, you also have to do to the numerator. So as a result, if I multiplied the denominator by 7, I have to multiply the numerator by 7. And that's what I'm just going to do right here for now. I'm just going to write that as 7 times 3. Perfect. Now I'm just kind of working left to right. So there's my plus from right here. Down it goes. And now I work with the right fraction. And all I ask myself is, well, what did I multiply the original denominator by to get the new denominator? Well, how many times does 14 go into 56? It goes in 4 times, so that's what I multiplied it by. So I took that 14 and I multiplied it by 4, which means in this fraction, if I multiply the denominator by 4, then I have to multiply the numerator by 4. And that's exactly it right there. Now, if you can get this far, wow, that is awesome. I think the process will make sense. So conceptually, if you can get here, that's fantastic. The rest is just algebraic manipulation. And let's see if we can simplify. So we did step 2. Rewrite each rational expression with your answer from step 1 as the denominator. Done. Step 2, perform the operations on the numerator. And as I said, order of operations, multiply comes before addition. So we're going to do 7 times 3. So I get 21, 1 times 4, looking great, all over 56. Again, we keep the denominator and kind of running out of room down here. So I'm going to bring it right up here, everybody. And it looks like 25 over 56. Awesome. Now, that's a very concrete example, one you've seen probably many, many times before. Notice the process that I took. LCD, rewrite, what did I do, and then simplify. I'm going to try to keep it exactly the way I did it in example 2A as we move into the more abstract part, which would be 2B and 2C. So with that said, let's go get them. So off to the side. LCD. So we have to be able to factor. That's the first order of business. And it looks like I have a little quadratic in standard form, and I'm seeing that I can pull out an x there. So I hope you guys see it as x plus 1. The right denominator, it looks like just a product of 2 primes, so that's ready to go, 2 times x. And remember, if you need to connect anything there. It looks like common is the x, so I connect those. And as a result, as I work left to right, I've got that common x. I've got the x plus 1. And it looks like I've got a 2. I'm going to throw the 2 out in front there. So LCD, everybody, is 2 times x plus 1. 3 factors. Keep that in mind, if you would, that our new denominator will be made up of these 3 factors. Awesome. Now, again, it works well for me to rewrite it. If you could care less, that's fine. I actually like rewriting this in factored form too, just FYI. Just from a visual perspective, I think it works really well. But again, guys, you do what works for you. So let's see. I want to make sure I've got everything ready for you. So 5 and then 2x. All right, super. So we have our 2 fractions. We want to combine them into 1 via addition. So I'm going to go ahead and create my 1 big fraction here with our new and improved denominator, 2 times x plus 1. That's looking great. Now the question is, how did I change each of the original denominators to get this new and improved one right down here? So if you notice, and this is where the seeing really comes into play, we had x and x plus 1. Now I have 2x, x plus 1. Well, obviously, I multiplied this by 2. And so that is what allowed me to create that new denominator from this original denominator right down here. Well, again, if I multiply the denominator by 2, then I must multiply the numerator by 2. And that's what I'm going to write right here. So 2 times 3. And again, if you can shortcut this a little bit, by all means. All right, super. Left part's taken care of. There's my plus. Now I look at the original denominator on the right, and it's made up of 2 factors, 2 times x. And I look down here at our new one, and it's made up of 3 factors, 2 times x plus 1. Well, what did I multiply this by? It's got to be this. I had to multiply that by x plus 1 in order to go from here to here. Well, I've got to multiply the numerator by x plus 1 also. And so I'm going to do that. All right. Again, if you can get this far, you've got the concept. Now, if you can get the correct answer, then your algebra is pretty intact as well. Cool. All right, let's see what we get. 2 times 3, not too bad. If I distribute that in, looks like 5x plus 5. And then all over, again, keep that denominator. Hope that makes sense. Hope you all know how that works out conceptually. Perfect. Let's just combine like terms. It looks like the 6 and the 5 will go together. So I'm just going to have to bring that right over here. And then I'll box this up for you, 5x plus 11. And then over that LCD, which is 2 times x plus 1. Wonderful. Now, one last thing before we move on to part C. If you remember, we're talking about rational expressions. And rational expressions are fractions. And what do we have to be very careful of in a fraction? That denominator can't be 0. So what values need to be restricted? What can't x be in order to make this a legitimate algebraic expression? So we want to look at this right here. But we also want to go back and look at the original to make sure we've kind of accommodated all the original fractions as well, because those are what we used to create this. All right. Well, anyway, I kind of look at this, and if I look at these 3 factors and I set them to 0, it looks like, don't worry about the 2, but if I look at that x, well, that x can't be 0 there because that would make the whole darn thing 0. And then I have a factor of x plus 1, and so I can't have x be negative 1 as well, because that would make the denominator 0. And if I look up here, I guess these would be the 2 denominators. It looks like that bears out. You know, I can't have x be 0, and I can't have x be negative 1. Okay, good. Let's move on to the next piece. All right, 2C. What I would love to happen in this particular case, and you really get a sense of if you're getting it, is see if you can work ahead of me. You know, you can have me kind of talking in the background or just pause for a moment or two. See if you can get this one, because this is, again, this is probably the upper level of what we're looking for. All right, so with that said, let's get that LCD. Have to be able to factor, guys. That's the key skill of all this stuff. So looks like here, if I factored that, x plus 7, x plus 1. And if I factor this one, it looks like x plus 1 and x plus 1. I'll make that a little better for you. That looks nice. So I look at both lists, and I just decide if there's a commonality to both of them. Looks like that x plus 1 in this one is the same as that x plus 1 right there. So let's connect them, and then just work left to right. So x plus 7. Here's the common x plus 1, but here is an extra x plus 1. So there are my 3. Okay, so now we've got this. I'm going to rewrite, and I'll try to do it as quickly as possible. If you want to do the same, great. If you're like, forget that, that's fine as well. Again, it helps me. Oh, in fact, how forgetful I am, I think it's easier to write it in factored form. So I'm going to do that right here. So let's do it as x plus 7, x plus 1, and that's a good reason to rewrite it anyway. More and more that I think about it, the more and more I like it. So x plus 1, x plus 1. All right, so let's go ahead and write a single fraction with that LCD, which is x plus 7, x plus 1. If you want to do a squared on that, that's fine. I'm just going to write the other x plus 1, just, again, better visually. Okay, here we go. I look at the old denominator on that left-hand side, made up of those 2 factors. I look at the new denominator right down here, now made up of 3 factors. So what did I multiply this by to go from here to here? Hopefully you're starting to see that if it's x plus 7 and x plus 1, well, I have another x plus 1 down here, and that's what I multiplied it by. So I've got that. Anything I do to the denominator must do to the numerator, and that's looking great. So x plus 1, 2x minus 3. Perfect. And then minus. And this is where it's going to get intriguing. The subtraction makes it a little harder, just so you know. All right, now I look at this. Old denominator, x plus 1, x plus 1. New denominator, these 3 factors. Well, what did I multiply that by to go from here to here? Obviously, it had to be that x plus 7. And as a result, anything I do to the bottom, I'm going to do to the top. Perfect. So, x minus 2, x plus 7. Sorry for repeating myself here, typically do, but if you can get here, That's fantastic. You've got it. Now let's see if we can go the full distance. So remember, it's just simplifying the numerator. That's really what it comes down to at this stage. Multiplication first, so foil, and then big subtraction. We'll be careful on that. So I'm going to show you how it played out on mine. Maybe you can work on it, I don't know, ahead of me if you get a chance. But if I FOIL these two right here, I get 2x squared minus x minus 3. Here's my minus symbol that's going to come on down. Now with subtraction, I'm always a little more careful. So as soon as I see subtraction, I always kind of put a left parenthesis there because it's going to be minus the entire polynomial. So I will implore you to just be super careful with subtraction. That is by far where I see most of the mistakes. So if I FOIL these two binomials together, that's what I get. All right, over the LCD. X plus 7, x plus 1 squared, or just another x plus 1. Okay. Well, let's combine the like terms, see what happens on the restrictions, and move on to the next piece. So 2x squared minus 1x squared is x squared. Negative 1x minus 5x means I've got negative 6x's, or minus 6x. Negative 3 minus negative 14. So be careful about subtracting a negative, and that's what that means here. That's why the parentheses really help, because you can see this goes into each of those terms. And looks like you get a plus 11 as a result. Perfect. And then over x plus 7, x plus 1, x plus 1. Restrictions on the domain, I'm going to be a little quicker with this one. I look at the factors in there, just make sure everything is aligned with the originals, but it looks like x can't be negative 7, and x can't be negative 1. Put that in play. Hopefully, at this stage, we can all take a collective breath. And those two operations, addition and subtraction, the process makes sense. The expectation on the simplifying to the very end in order to get something like this is all in place. And then we can take the next step. All right. I'm going to move on to my next board. And we're going to work with something called compound or complex fractions. And so you'll probably just write a few things in that I ask you to write, and then obviously we'll just get a little practice with it. So here goes. Compound or complex fractions are very simply fractions within the overall fraction. So fractions within fractions. And you'll see a bunch of examples down below there. So you get a sense of what I'm asking and what I'm looking for. And quite frankly, there are really two good ways to pull this off. So here's what I'm thinking. As I wrote on your paper, there are two methods for simplifying these compound fractions, and that's all it is. It's not necessarily an operation, but what it is taking something that's very complicated and putting it in equivalent but more simplified form. So two methods. Truth be told, I'm going to just let you read through them both. This is the more formal method, by the way, method 1. And if you want to explore method 1 with me, or maybe you've seen it in a previous course and that's just what works for you, it is not for me to judge by any means. I can help you with that as well. I'm going to go towards method 2. I just think method 2 is, once you get the hang of it, much, much quicker, easier. It's just more fluid than method 1. So if you don't mind, I'm going to focus on this. If you have questions on this one, you know what to do. Just ask. Easy as can be. So method 2, it reads, find the LCD. So here's that LCD coming up again. Of all the rational expressions in its numerator and denominator, then distribute the LCD into the numerator and denominator of the overall fraction. And of course, what do you say, throw a little underline there, simplify the darn thing. Now I was thinking, I sort of put this here. Truth be told, I'm not too concerned about this, and I was thinking I would do it maybe after the examples, but I'm thinking more and more I'm just going to put it before the examples and maybe touch on this as we go through. So the question is, why can we do it? Why can we multiply into the fraction itself? And so here's what I wrote, and if you don't mind doing the same, but basically multiplying the numerator and denominator. Remember, whatever you do to one, you have to do to the other. So multiplying the numerator and denominator by the same term. Is just equivalent to multiplying it by 1. Anything you do to the top that's on the bottom, if you're multiplying by the same thing, 2 over 2, 5 over 5, x plus 1 over x plus 1, well, whatever it is, it's equivalent to just the number 1. So equivalent to multiplying it by 1. And when we multiply something by 1, we don't change its value. So that's the idea, is we're changing its form, but not its value. And if you want to write that in, that's probably a good idea too. So we are changing the form of the fraction, but not the value of the fraction. Awesome. Okay, so I've got 4 of them. And truth be told, if you can get the first 3, wow, that's fantastic. I'll talk about a letter D in just a little while when we get to it. But let's not forget, so let me read example 3. Simplify each compound fraction. And obviously we're talking about these rational expressions, so we'll deal with the domain as we go through. All right, now, here's what we do. I'll try to keep consistent across the board. That's the best I can do for you, is whatever I do to one problem, I'll do to the other, and the other, and the other, and hopefully it'll click. So what we need to do, there are 4 fractions, 1 over 1, 1 over x, 1 over 1, 1 over x. What we need to do is basically just find the LCD of these 4 fractions. So if I look, I've got 4 denominators, obviously 1 over 1. Then x is another denominator. 1 is another denominator, and x is another denominator. Those are the 4 denominators of the fractions within this overall fraction. Hopefully everyone is starting to get a sense of what that means, fractions within the overall fraction. Now LCD, hopefully it's getting more and more second nature. Let's connect those guys, let's connect those guys. So as I work left to right, it's just 1x, or obviously just x. And that's what I'm going to do. This LCD here, guys, is going to be x. Now, here's how it plays out. You can do this a couple different ways. I like the rewrite, everybody, so I'm going to do that. If you don't like it or feel it's necessary, don't bother. Now, here's what I'm going to do. The numerator of this overall fraction, I'm going to throw in parentheses. The denominator of the overall fraction, I'm going to put in parentheses. And what I'm going to do is take the LCD, exactly what it says up above on your paper, and I'm going to distribute it in. Hold on one sec. Never mind. Okay, so as I was saying, what I'm going to do is take that LCD and I'm going to distribute it in to the numerator of the fraction, and then I'm going to distribute it in to the denominator of the fraction. Now here's how I do it, everybody. I'm going to actually write the LCD, and I'm going to put it over 1. Again, as you do these, if you get the sense like, oh, I don't need to do that, then don't bother. I've found just working with students over the years, it's just helpful visually, and you'll see why I mean that. But so LCD, just put it over 1. Anything I do to the numerator, I do to the denominator, so that's it right here. I'm going to multiply the numerator and denominator by x. Awesome. Well, let's go ahead and distribute. So I got my x times 1. So just multiplication, guys. That's all it is. This distributes in. X times 1 is just x. Perfect. There's my plus. Distribute it in. And this is why I put it over 1. Because you can see that this x is sort of sitting on the numerator, but I also have this x in the denominator over here. Well, what happens when I do multiplication? What happens to this x and this x? Well, as we hopefully do remember, multiplying these fractions together, this should cancel out with that. These two go away. They're gone. And then I'm really just left with this 1 right here. And I hope you kind of see that piece. When I multiply x by 1 over x, these cancel, and I'm left with that. And that's the idea, everybody. That's, when we talk about, well, what's the outcome that we're looking for? It's to get rid of these denominators within the overall large fraction. So this x has to go. And when I multiply by that on top there, gone. Cool. Let's just repeat. So x times 1 is just x, and then x times 1 over x. So I'm going to put my minus there, by the way. And so when I do this, x on top, x on bottom, that cancels out with that, and I'm just left with this right here. And that's it. Notice how much more simply this is expressed than what we started with. This is what's called a simple fraction. That's a compound fraction. Same values in here work as they did here. Okay, before I do forget, restrictions on the domain. Looks like x can't be 0, so I go back to the original. So if you look there, x couldn't be 0. That would be real trouble. But I also look at the new one here, and I look at my answer, and wow, x can't be 1. That would be bad as well. So original and new one. Make sure you do check. All right, so I have to say that was probably on the easy end of the spectrum in terms of compound fractions. This is a good middle ground problem right here, so is part C. So let's see if we can handle it. I'm going to try to do the exact same thing, guys. I'm going to try to express it the same way. Consistency is important. So 4 fractions, right? 4 denominators, x minus 2, 1. This is x plus 2, x minus 2 when I factor it, and that's going to be 1 right there. So 4 fractions, 4 denominators. 1 is x minus 2. In fact, I'll just throw some parentheses there. This is 1 over 1, so denominator of 1. That factored, as I said, x plus 2, x minus 2, and denominator of 1 right there. So remember this, what I mean by denominator of 1, by the way, is that's kind of a 1 over 1. If you need to kind of write that in to see it, so be it. Okay, connect x minus 2's. What is the LCD? I'm hoping you see it as x minus 2 and x plus 2. That's our LCD. All right, very cool. I'm going to rewrite, and let's go to work on this thing. And just like I did before, I think on example 2, way back when, I'm going to rewrite that in terms of its factors. I think it's just so much better. The more I think about it, the more I like it. Okay, parentheses, numerator, parentheses, denominator. Now, what we're going to do, we need to get rid of these denominators of these smaller fractions within the overall fraction. So as a result, I'm going to go ahead and multiply by the LCD. Again, that is the strategy we are employing here. Again, I put it over 1. If you don't like it, as I have stated, yeah, don't bother. Okay, so this is going to distribute into these 2 fractions. This is going to distribute into these 2 fractions. As long as it's the same thing, then I'm not changing the overall value here. I'm going to try to work off to the side, kind of like I did last time. See what happens. And if you're starting to get the hang of it, just go for it. Definitely. All right, so now, when I multiply this fraction right here into this one, then let's see what happens. X minus 2 on top, right? X minus 2 on bottom, right? Shouldn't that cancel with that? It does. Yeah, and that's the idea. This had to go. So by having this up here, that cancels that out. And now notice what I'm left with. When those 2 x minus 2's go away, these are the only 2 things that are left, and I multiply them together. I'm going to go ahead and just stretch it a little bit. If I multiply x plus 2 times x, I get that right there. If you don't like that, that's okay. All right, now, when I distribute this into the 1, is there anything that needs to cancel out or anything like that? No. So let's just multiply this into that. So x minus 2 times x plus 2 times 1, and that would be, and let me put the plus, by the way, in there, just x squared minus 4. Perfect. Bottom. Okay, these have to go. That's what's causing all the ruckus here, so let's get rid of them. Well, if you notice, the x minus 2 that's the problem, there's 1 right there. The x plus 2 that's the problem, there's 1 right there. Those x minus 2's are going to cancel. Those x plus 2's are going to cancel. So envision that all going away. And when that all goes away, what's the only thing that's really left? The 3 here and the 1 here. Well, 3 over 1 is just 3. All right, and last but not least, distribute that into the 1. Is there anything that we have to worry about canceling? Nah. So just this times 1, and it's just the x squared minus 4. Now, guys, it's just a matter of playing cleanup. That's all it is. So combine like terms. I've got 2x squareds. Let's see, I've got 2x's minus 4, and down on the bottom, x squared minus 1. Now, I have to tell you something. If you can get this far, that's great. Honestly, it's pretty much end game. We would state the restrictions and move on. It just so happens that this numerator factors and the denominator factors to get a more simplified version of this. I'm going to write that down. You're not going to panic about this. This rarely ever happens. But if I factor the numerator, let me just kind of show you here. I'm going to bring this on up. I get 2, x plus 2, and x minus 1. And the bottom, of course, difference of 2 squares is x plus 1, x minus 1. So do you notice when I actually write each of those in factored form that the x minus 1s are common to the numerator and denominator? So theoretically, if we really went all the way through, that would be our final answer. As I said, you're not going to worry too much about it. If you got here, consider yourself lucky. Restriction. Before I do forget, we have to look at our final answer and kind of work backwards too, because all this simplifying, if they have issues, those issues carry over to the very end, because this is what we started with. All right, well, I do know x can't be negative 1. And actually from here, just a step before, can't be positive 1 either. And I look up here, x can't be 2. And then I look here, x can't be negative 2 either. So, you know, looks like 4 exclusions. If you have issues with the restrictions, don't worry too much about it. We'll keep crossing those bridges as we come to them. All right, guys, on to C. So letter C, LCD time, everybody. Let's go give it a try. And if you want to work ahead of me, totally would encourage that. So 4 fractions means 4 denominators. So 1, 2, 3, and then a 1 under that 5. So x plus 1, x plus 1, and 1. Connect the common. And it looks like I would get an x. I'm just going to put that out in front. X plus 1. That, everybody, is your LCD. Hopefully at this stage of the game, you're able to get that pretty quickly. I'm going to rewrite, and let's go finish this up. Okay, parentheses, numerator, parentheses, denominator. Looks super. LCD out in front here. If you don't want to put this over 1, don't. Remember the end game. That's a problem. That's a problem. That's a problem. They all got to go. So by doing this step, we should be able to remedy the situation. So let's distribute, everyone. Here it goes. This into this. When we multiply these 2 fractions together, do you see this x plus 1 on the denominator? Well, do you also see this x plus 1 in the numerator right up here? Goodbye. Good riddance. There they go. Well, when these x plus 1s go, what's left? You've got the x, and you've got the 2. And so multiply those together, and it's 2x. Hopefully you see it. Those go away. That's left, and that's left. Okay? Repeat this into this. That's got to go. Well, how does it get eliminated? Well, that x right here on the denominator is the same as that x on the numerator. They're going to cancel out. When that cancels with that, I have the x plus 1, and I have the 3. And if I multiply those together, if you don't mind, I'm just going to go ahead and do that, 3x plus 3. Let's repeat down on the bottom. X plus 1s are going to go. That's the idea. And I am left with an x, and I'm left with 4. Here's my minus. Lastly, is there anything to eliminate down here? No, because think of this as 5 over 1. Nothing to eliminate, so let's just multiply across. And with the minus, I'm always a little more careful, as I've stated before. So this would be, I've got 5x squared plus 5x, right? Cool. All righty, guys, clean up. Numerator, 5x plus 3. 2x and 3x make 5x. Denominator is a little harder. If you notice, that minus will go into both of these. Just remember that. So I've got a negative on that 5x squared. And then 4x minus 5x would be minus 1x. That's awesome. How cool. I'm just going to give you the restrictions on this one. It's a little harder. Don't worry about it too much. If I do look at the original, and that's the key, look at the original, then look at your answer and start to think of, all right, well, what can't happen? What can't x be to make it the denominator 0? Looks like x can't be -1 because that would be trouble right here. It looks like x can't be 0 because that would be trouble right here. And it just so happens x can't be -1/5. If you kind of look at this, that would be a problem. Again, I won't go into too much detail here. But if you have questions on that, you let me know and I'll walk you through. Okay, 3 good compound fraction problems. Truth be told, if you can get through C and understand the process, how to do it, simplify from here to here, you've got it. That's it. Now part D, honestly at this stage, here's what I'd say. Part D comes directly from a calculus class. So there's some manipulations you do with this x plus h and this h on the bottom that produce exactly this expression. And when you get to that class, you'd be expected to simplify something exactly like this. So I'm going to do that for you. But I would say at this stage, if it's kind of run its course for you, you are more than welcome to stop the video at this point and try some of the practice problems. There won't be anything that dramatic like this on there, so don't stress about it at all. It's not like you're missing out on anything. But if you have an interest in seeing how something like this would get simplified, perfect. Okay, I'm going to go for it. Now in this particular case, I'm going to put that over 1. And I'm going to look at my LCD. And that's a denominator, so x plus h. That's a denominator, so that's x. And then obviously 1. And so I hope you can see LCD is x plus h. Perfect. All right, so rewrite. I think it's helpful here to throw that over 1, but if you don't like that, don't bother. Okay, numerator, denominator, LCD's coming out. Let's see, x and x plus h. All right, equals. Let's see what you get. X plus h on the denominator right there, x plus h on the numerator, they're gone. So once those go, you're left with x and 1. You multiply them together, and you just get x. Minus, and just be careful with the minus. That x has to go. That's the goal. Well, in order to get it to go, I need an x in the numerator, and there it is. So that is going to cancel out with that. When the x's cancel, I'm left with x plus h and the 1. Multiply them together, and you just get x plus h. Now the denominator, if you notice, kind of down here, there's nothing really canceling. Like I don't care about something being over 1, so that's not an issue. So I'm just going to multiply these straight across, 3 factors. I've got an x, I have this h, and I have x plus h. Perfect. Now, notice this is the one mistake I would always see on this. Don't forget that minus goes into both of those. So I have x minus h. I hope you see that the x's would cancel. X minus x is just 0, but then I've got a negative h. And then the denominator is made up of just 3 factors. I really liked leaving that in factored form. X and h and x plus h all multiplied together. Pretty good. If you got that far, not bad at all. One more step though. Canceling common factors. We talk about it all the time. That's why I left this factor down here. If I want to simplify a fraction, I look for common factors. The h is common to the numerator and denominator, so when they cancel, that becomes -1, x plus h. All right. Hey, look, if you have any questions on these, you just let me know. Get some practice with the addition, subtraction, and the compound fractions, and see what emerges. Thanks, everyone.